Welcome everyone. Hopefully be able to see messages coming in the chat. Welcome guys. I hope we're all having a good weekend, and we're looking at a nice GCSE topic today, looking at decimals and kind of the ways it can come up in the GCSE exam. Do feel free to say hi, ask any questions, share answers as we go today as well. It'd be great to hear from everyone. Welcome, as I said, if you're just joining, and do feel free to say hello. I'm going to share the screen shortly and we'll get started. So we're looking at decimals today, and we know the GCSE exams are kind of coming up, swiftly approaching. They're kind of around the corner now, and there is a bit of information as to what's going to appear in the exams. Decimals and the number work is kind of really a common topic every year, but it will be one of these definite things we need to be careful and confident with in the exams. It's kind of an all or nothing kind of topic, and we want to know exactly what we're doing. So do feel free to say hi if you haven't already, and I'll keep an eye on the chat throughout. I'm going to share the screen now, so we'll get started shortly. Let's do that now. Right, so hopefully in a second you'll be able to see the slides. Welcome. Hi, nice to see the comments coming in. I hope we're all doing well. Great to see comments in the chat, and hopefully that'll carry on throughout the session. I hope everyone's keeping well. Right, here we go. So hopefully this screen is now sharing with you guys, and I'll check that I can still see the chat and everything. Yeah, brilliant. So I hope you're having a good weekend. We're going to be looking at decimals today. So a kind of very obvious number topic that appears in the GCSEs that hopefully we're fairly confident with. And we'll look at some of the ways that this can come up in exam questions as well. Do feel free to say hi if you haven't already. We're literally just getting started. And it's crazy how quick this academic year is going. It feels like we're kind of quickly approaching exam season already. So it'll be nice to get on with this topic here. Decimals, I'm going to share the slides now, just make sure I'm geared up so I can still see all your comments, questions and answers coming in. Hopefully this will be quite a nice one to whiz through. And yeah, let's get started. So I'm Max, I'm head of maths at Snap Revise, and I did a maths degree a few years ago now, and I've been teaching maths ever since. So to GCSE, to A-level and Key Stage 3 as well. So it's been a really interesting time with changes to exams and the past couple of years as well. So especially at the moment, we're kind of in quite a unique situation where the exams this year are hopefully going ahead, but we've got kind of information about that, and we can therefore kind of prepare accordingly. So we're going to get started with this topic today. The main things we're going to look at, we're going to recall basic conversions between decimals and fractions, solving addition and subtraction problems involving decimals, and looking at multiplying and dividing decimals together. I'm not going to do recurring decimals or standard form, although they are kind of obvious extensions to this topic. So they might be the kind of things you guys want to practice as well going forward. So we're going to just make sure our understanding of decimals is really secure, and it'd be great to hear from you in the chat, questions and answers as we go. Do feel free to say hi at any point. It'd be great to hear from you if you haven't already. Brilliant. Right, let's get started then. So this topic, decimals and fractions, decimals, percentages, is a key part of number, and it doesn't really matter what exam board you're with. This is definitely a part of the GCSE maths content. So it's a really important topic to be confident and happy with, and we're going to see how we go. So let's have a little look. So to start with, hi, welcome. Great to hear from people in the chat there. I hope we're doing well. We're going to get started. Do feel free to share answers and stuff as well. Hopefully this isn't going to be too bad to begin with. So stuff we should already know. The kind of setup, the general place value setup, if we've got a decimal here, then we're dealing with 1 as being the units column. So that's like 1 times 10 to the power of 0. So this kind of ties in with standard form. 8 is basically representing 80. So 8 times 10 to the power of 1. And then we've got 1 lot of 100. So 1 times 10 to the power of 2. And then does anyone know what powers of 10 the decimals are? So this place value here is a tenth of a whole unit. So if it's a tenth, does anyone know what that is as a power of 10? Does anyone know how we can write that as a power of 10? And this might tie in with those of you that have done standard form before. because we're effectively doing 3 times 0.1. That's what that represents. But that's the same as 3 times 10 to the power of what? Brilliant, excellent. Thanks, Janella, or whoever's just answered in the chat. I've just seen that come through now. Well done if you've worked that out as well. That's to the power of -1. So this one here would be 2 times 10 to the power of -2, and then 7 times 10 to the power of -3. So 0.001, and then we times it by 7. So that's breaking the number down. And hopefully that's something we've kind of come across using kind of base 10 as our system. Welcome. Hi, if you've just joined. So we're just kind of going through a bit of prior knowledge for decimals. Multiplication and division, hopefully we're happy with as well. I think the most common methods we use, I'm guessing for multiplication is the column method. But if you've got any other methods you like to use, do suggest them in the chat as well. Welcome, guys. So we're going to do 3 times 4, so 12, 3 times 1, but it's really 3 times 10, so 30. And then we move over to here, 5 times 4, so it's actually 50 times 4. So we're going to put the zeros in place. That's going to be 20, and then 50 times 10, that's going to be 500. Add it all up, and there we go. We get our answer. And then for division, I think most people are hopefully happy with a sort of bus stop or shoebox method. It depends what we call it. And we put the number within there, and then we just sort of work through the number each time. So 6 doesn't go into 4. 6 into 49, it goes 8 times with a remainder of 1. It goes into 10. So into 10, it will go once with a remainder of 4, and then that will go into 42 7 times. So that's the kind of short division. You may also have learned long division as well, where you sort of take off the multiples of each amount. So that's great. Does anyone here use long division instead? Does anyone prefer long division? So sort of subtracting off each time and working down. Let me know, it'd be interesting to hear. Sometimes people learn these techniques differently. Yeah, the shoebox method. Yep, I like that. Yeah, long division does seem very tedious sometimes, but it is good to know. But yeah, that I agree. Okay, so converting and adding decimals. Let's have a little look. So hopefully this will be okay. And obviously the first paper you come across at GCSE will be the non-calculator paper. So just being hot on these skills and confident with decimals and converting and so on is really important. I know it's a bit of a kind of safety net to have the calculator, but we do also need to know how to do all of this stuff, because as I said, it will be all or nothing with the marks. So it's easiest to convert between fractions and decimals by kind of just using the known ones. So using known fractions and decimal conversions. So there's a few that I would say it'd be really handy to sort of know by heart. So if this is quite straightforward for you, that's brilliant. But if there's any here you want to share, and then we can look at some tricks. So a half, hopefully everyone's happy. What is that as a decimal? And you might remember it through learning percentages. So 0.5, excellent. And then a fifth. So a fifth is the same as 2/10. So hopefully we're happy with that one as well. That's actually one that does confuse a lot of people, 1/5. It's very easy to rush and get that wrong. So that one, 1/5, will be 0.2. And then 1/10, hopefully we're happy. Do feel free to share it in the chat. So 1/10 is what as a decimal? And it's lovely to see the answers coming in the chat there. So very well done. 1/10 is going to be, think of it as a percentage, it's 10%. 1/10 as a decimal, excellent, 0.1. And then a quarter, we can think of as a half of a half, or as a percentage. So it's like 0.5 divided by 2. So it's 25%, or 0.25. That's great. No, they've all been good so far. Well done. 1/25. Now this one, it's quite easy to go wrong here. The way to do this is actually use ones we do know. So we know that 1/5 is 0.2. Is everyone happy that 1/25 is a fifth of a fifth? So it's like 1/5 times 1/5. Or 0.2 divided into 5. A 25th is the same as a fifth of a fifth. Is everyone happy with that? So this one is actually, if you did 0.2 divided by 5, I'm going to break this down a bit more, then that would actually be 0.04. Okay, so I think 1/25 is one that people sort of struggle with. But what I want to kind of help you guys do is, if you know some of these known fractions at the start, we can often work out the more difficult ones by dividing up the fractions we do know. So for example, this one here, 1/10, 0.1, this is 10 times smaller. 1/100th is 10 times smaller. Does everyone agree with that? That that's 10 times smaller than this? So you can take this answer and just divide it by 10. Make it 10 times smaller, shift it down a column, and you'll get 0.01. Does that make sense to everyone? Do let me know. It's great to have questions coming in, and do ask if there's anything you want me to clarify or reiterate, because as I said, these will be so kind of super handy for the non-calculator paper to be absolutely happy with these decimals and knowing these fractions to decimal conversions. Super. Right, 1/8. So again, if we think of it, it's a half of a half of a half. 1/8 is a half of a quarter. If I have a cake split into 4 bits and I want to split it into 8 bits, I could just half all of those bits again, and then I'd have 8 parts. So if I know that a quarter is 0.25, which is like 25%, I could half that, which would be 0.25 divided by 2 if I half it. And that would be like 12.5% or 0.125. So knowing that that's an eighth is really handy as well. So what I've kind of done with each row of fractions is broken down one of the known ones. So a half is 0.5, a quarter is half of that, an eighth is half of that. And then we did a similar thing with a fifth. We found a 25th by dividing that into 5. Yeah. Oh yeah, good question there. 1/8 is 1 divided into 8 parts. That's a very good way of thinking about it. So a fraction is effectively a division. So 1/8 is 1 divided into 8 bits. If you had 8 of these, you'd get 1 whole. Like if you had 12.5%, 8 times, you'd get to 100%. So it's 1 divided into 8 because it's smaller than 1, isn't it? It's 1 broken into 8 equal parts. Brilliant question. Yeah, absolutely. Great question. So then 1/50th, 1 broken into 50 tiny equal pieces, is kind of like 1/25th, which we now know, halved. Okay, so if we take a 25th, which is 0.04, and we half it, we're going to get 0.02. And if you think about it, 1/50th, that's like 2%. If you had that 50 times, you'd get the whole 100%. So that does work as well. And some people do find it easier to get decimals from finding the percentages, which is absolutely fine as well. So that's great. And hopefully that's kind of clear to everyone. We're going to keep going with this because I think this conversion thing is really important. Any answers for this one? So very similar thing again. Look at the pattern here. 1/10, 100th. What about 1,000th? What would we have as the decimal equivalent of that? 1 divided into 1,000 parts, 1,000 equal parts. What is the decimal equivalent for 1/1000th? Any ideas? Let me know in the chat. And thank you very much as well, guys, for all the answers so far and the questions as we've gone. Absolutely right. Brilliant answers there. 0.001. Lovely. And if you're thinking this is quite straightforward, excellent, guys. That's great. It's this kind of confidence we need because, as I've mentioned, in the non-calculator exam, which will be your first paper for GCSE, it will be all or nothing, these kind of questions. You have to make sure we're absolutely happy. And these are ones that are really good to know. So we're going to look at some slightly trickier ones, go through a few more fairly straightforward ideas, and then do some exam questions to see exactly how this will come up in an exam, or could come up in an exam. So again, going back to a question or a comment from the chat for a minute ago, think of the line in the fraction as an actual division. That is what it signifies. So this is really saying like 7 divided by 2. So you can think of it as, well, what's half of 7? What's 7 divided by 2? But you could equivalently think of it as a half times 7. Okay, this is the same as 7 times a half. Now we know that a half is 0.5. So 0.5 times 7 is 3.5. So you could have worked that out either way. If you were happy to just say 7 divided by 2, and you know how to do that, that's absolutely fine. But equivalently, we could scale up those fractions that we know. Superb. Right, so if the answers are coming in, that's superb. Now, 3/4, let me know if you know that as a decimal. We knew that 1/4 was 0.25 from the ones I mentioned that we should hopefully know. 1/4 is 0.25. So 3/4 is 0.25 times 3 of them. And what do we get? And then, guys, if you want to work this out, that would be great. So we're going through the slightly trickier ones. Brilliant, 0.75, lovely. Now, 5/8. We had 1/8 was 0.125, and we got 5 of them. So what do we get for this one? And it's just over half. So you might think, well, 4/8 is a half, that's 0.5, plus another 1/8 on. That might be a way of doing it and jumping there a bit quicker as well. Superb. And then we'll look at what else we can sort of spot. So the other kind of conversions we can do as well. So what do we reckon? Yeah, absolutely right. Yeah, good. 0.625. Very well done. And I know that this topic, decimals and number work, can sometimes feel so kind of boring and kind of a little bit tedious. But actually, we have to know it, and we have to be able to do it for that non-calculator paper. And it is these sort of things that will cost people marks. So very well done for paying close attention to detail here. Right, the next one, I'm going to show you guys a little trick of something you might notice. You might have noticed that 0.125 divided by 2 is this number. Maybe not, but hopefully if I give you that hint, we'll be able to see, okay, if 0.125 divided by 2 is this, what could I do? How could I write it as a fraction? So, of course, on a calculator, you would be able to work these out. But what we're trying to do is get prepared for the non-calculator exam, where the more of these that you can recognize and be confident with, the better for that exam. In the calculator paper, absolutely. And you'd use the calculators to your advantage there. So this one is basically 1/8 divided by 2. So this is equivalent to a 16th. I think that's a bit harder to spot. This one, though, we might be able to spot, okay, what is this as a fraction? And you might like to give it as a mixed number, or you might like to give it as a top heavy. Let's try and give it as a mixed if possible. What is this as a fraction? Let's do these next couple and see how we go. So 2.25, what is that equivalent to? And if you guys want to share the next few in the chat, that would be brilliant. Okay, right, so 2.25. So it's the whole amount is 2, and the fraction or the decimal we're left over, 0.25 spare, is 1/4, so 2 and 1/4. Absolutely. And this one here is going to be 1 and something, and 0.125 we hopefully recognize, or we're starting to recognize as 1/8. No, that was all good. That was fine. 2 1/4, lovely. And 1 and 1/8. Good. Right, 2/5. We know 1/5 is 0.2. So if we've got 2 of them, that is 0.4. And it might be easier to spot if we remember 2/5 is the same as 4/10. And then it's maybe a bit more obvious that that's 0.4. But a good one to go through. Right, I'm going to whiz on with a few more of these. So as previously mentioned, these are the ones you guys are probably going to want to really know for comparison. So if you want to take a screenshot, make a note, or just be absolutely clear on those, unless you are already, because that's what's going to help going forward with some of the tougher ones. So we're constantly referring back to these. 31/25, again, is top heavy. So yeah, lovely way to think through that. Excellent. So that was nice. Thanks for the answers there. I was going to say one way of doing it was 0.04 times 31, which is 1.24, but I actually think the suggested method in the chat was better. I think that's a really lovely way of seeing it. So very well done, making it out of 100. Excellent. Right, 17 out of 50. I'll carry on with this approach for now, but if you guys want to share what you think it is, that would be brilliant. And I know I'm kind of whizzing through it quite quickly, but well done if you're happy with this. And do feel free to share in the chat, as I said. Right, what I'll do, guys, if you want to let me know the fractions for the final three, this one is a really good one to talk through because it really kind of sums up this technique, this method that we're using. So the next one here, 0.9, what do we get for that one? So 0.9, hopefully we're happy. As a fraction, 0.9, we can write, you might think of it as 90%. Yeah, absolutely, well done. Brilliant, 9/10, which is 90%, it's like 90 out of 100. This one is 15 out of 100, superb. You could simplify that one a bit. If you divide both through by 5, that's equivalent to 3/20, but very well done. And this last one, I think, is a really good one to talk through. And I could see this coming up on a non-calculator paper because it catches people a little bit off guard. You might be able to compare this to 0.75 and think, okay, there's a little trick here. I'll come back to that. Some people would write this as 75 over 1,000 and then simplify it, divide through by 5, divide through by 5, divide through by 5, and then divide through again by 5, and they end up with 3. We could get 3/40. But can anyone see a sneaky kind of technique? How could I see 3/40 from this? What could I have compared this to? What does it sort of look like? Almost kind of, what do we recognize here? 0.075 is very like 0.75, but 10 times smaller. So if you guys know that 0.75 is 3/4, 0.075 is 10 times smaller than that. Excellent. So 10 times smaller than 3/4 is 3/40, because you're breaking it into 10 more parts. So rather than being out of 4, it's out of 40. So it's 3/40. And I think being able to spot that is really good. That's absolutely fine to do that because we know 0.75, 3/4. 0.075 is 1/10 of that. So it's 3/40. You're making the denominator, the kind of denomination of what it's split into, 10 times more. So it's 3/40. So I think that's a really worthwhile one to talk through. Brilliant. Does that make sense to everyone? We happy with that? I am going to move on. But I think that was a good one to look at because you can imagine something like that being in an exam. And if you can spot it, it saves you a lot of time and you can move on sort of with confidence. So we're going to keep going, but well done with that. So decimals can be added and subtracted. This one here, subtracted and added. I'm just going to write the notes quickly so we can keep going. So basically treating decimal places the same as tens, units, etc. So treating decimal places, and feel free to work ahead of me here and get the answers to these. Decimal places the same as units, tens, etc. I'm not sure what ones are scheduled coming up. I've just looked at some of the messages in the chat. Hopefully we'll be able to cover a few more topics coming up, but I'll maybe speak about that towards the end. Oh, well done if we've got an answer. Yeah, because obviously I know that there's probably key topics now you guys are hoping to focus on in light of the upcoming exams. But yeah, we can have a little talk about that towards the end. I'll whiz through this because there's a few exam questions I actually want to do with this now. Very well done if you've given this a go and you've already put an answer. That's great. I agree with that. That's brilliant. And then just being careful, kind of lining it all up. Particularly for these kind of column methods, we can put in something to fill the places, but we're doing subtraction here. We'll make sure we're looking out for what operation it wants. And here we need to borrow 1, 10 take away 1. We can get 9, 2 take away 1. Oh, there we go. And do feel free to share if you've worked ahead of me. Yeah. Yeah. Lovely. Well done, guys. Superb. Brilliant. Right, so we'll do a couple more. I'll let you guys have a quick think of. Then what we'll do a little checkpoint and we'll look at how this would come up in an exam. So what I want to do now, I'll just move that on. If you guys want to quickly give these a go, very similar, over a few more decimal places, let me know. And then, as I said, we're going to do some exam questions and move on to the next part of the topic. So that's really good. Thanks very much as well, guys, for your questions and your answers throughout. We'll keep going. This is great. So I'll start setting this up. But if you guys want to share your answers, I'm sure you'll beat me to it. That would be great. So I'll put a 0 to line it up. We're doing addition first again. And so 0 plus 2, 3 plus 4. Well done. Guys beat me to it. Let's so 3 plus 4. Here is 7. 4 plus 7 is 11. So we're going to carry the 1. 1, 1, 2. So 4 and then 3. So I think we'll just check. No worries. Do check. I'm going to check it as well. Yeah. So make sure you've lined it up carefully. The other thing as well about this topic, and it's something we can all easily do, is that it is about being just really super careful and slowing yourself down on the question. So I don't want to rush anyone today. Apologies if I'm rushing you guys a bit. The reason is because actually it's the kind of thing that you wouldn't notice if you went wrong. It could quite easily look kind of right. And I think it's also the kind of questions that, no worries. No. So that's a really important point, is that, and a lot of mathematicians go through this, is that we often develop sense checking techniques as we go, but it's sometimes these topics that are harder to check because they kind of at a glance look right. So when you're going back through your work at the end, you'd never spot it. And that's why on the question, we really want to slow ourselves down and make sure. Right, I'm going to just try this one here. And again, I'm going to try and make sure it's really neat and clear. 8, 9, 7, and we're doing subtraction. So 0 take away 7 we can't do. Borrow 1 from there. 10 take away 7 is 3. 2 take away 9 we can't do. Borrow 1 from there. Make it 12. 12 take away 9 is 3. 7 take away 8. This is getting a bit tedious, isn't it? We can't do. So we're going to borrow 1 from here. Make it 17, and that will be 9. Lovely. 5 take away 1, 4. 1 take away nothing. Well done. Lovely. Okay, cool. So I'm going to keep going. Just a little checkpoint, guys, whether you've shared answers or not, or questions or anything. If you could all let me know how you're feeling with that, just as a 1, 2, or a 3. And then what we're going to do, we're going to do a couple of exam questions and then go on to some techniques for multiplying and dividing. And you guys can work out, we might find some little shortcuts as well that will be helpful going forwards. So just a 1, 2, or a 3 to indicate how you found that content so far. And then I've got a couple of exam questions to look at, which might bring to light how this will come up in a GCSE exam, because it might be a little bit different to the way that we were doing the questions there. So let's have a little indication in the chat if you can, just a 1, 2, or a 3. And thanks again to all those sharing answers and questions throughout. Here we go. Excellent. Lovely. So I'm going to move this on. But if you guys want to let me know, just give me a little checkpoint. That would be great. And here we are. So the question here, write down 0.4, 15%, and 7/20ths in ascending order. So personally, the way I would do this is try to get them all as a decimal so that it's easy to compare. And the first one is sort of done for you. We know 0.4 is 0.4. So let's try and get the others as decimals so we can compare. So I would work through this in the following way. I would think of 7/20ths, and you might scale it so it's out of 100, so it's easy to write as a decimal, or you might say it's 7 lots of 0.05, and so that would be 0.35. Yeah, well done. And some of you may like the technique of how do I get from 7/20ths to, so it's out of 100, times by 5 times by 5. And then hopefully we arrive at the same answer. Lovely, excellent, brilliant. So that's a really good technique. And so well done for carrying that on. 15% is 0.15, and then 0.4 is 0.4. So if I'm going to write these in ascending order, that means in increasing size, the smallest one is going to be the 15%, because these are now quite easy to compare. 0.15 followed by 0.35 followed by 0.4. So I think decimals are great for comparison, and that's why in the GCSE exam we want to be confident with decimal conversions, because it will allow us to compare quantities really easily, especially when they're all written differently like this. So 15% followed by 7/20ths followed by 0.4. That is the 3 values there written in ascending order. Do we all agree with that? Is everyone happy with that? And you can imagine the question could be a little bit longer. There could be a few more values thrown in. But if we stick with that method, it's quite good. Okay, is that all good, guys? That excellent. Lovely. Right, so I'm going to keep going. And we've got another kind of decimal-based question here now. So I'm going to move on. Here we go. So 3 friends have their heights, excellent, lovely, have their heights measured. Ben is 1.4 meters tall, Joseph is 1.13 meters tall, and Layla is 0.95 meters tall. How much taller is Joseph than Layla? Excellent, thanks guys, lovely. So what we're going to do is we're going to work this out through what technique? Well, effectively it's a range, isn't it? So it's a subtraction. We're looking at a difference between the 2 values here. And the other thing we've got to be careful not to mess up is to quite easily we could pick the wrong person. We could read the wrong person's values. So if you guys want to work out that for me. Hopefully we agree, 0.18 meters. Very good, cool. And then this time we're comparing Ben and Joseph. So it's the same process again, actually. And I might give you guys a bit of thinking time this time. So it's this time it's a difference between this value and this value. So if you guys want to try that one, let me know in the chat. That would be brilliant. So 1.4 and 1.13. And we'll do the subtraction there. So let me know if you've got an answer for that. And then we're going to move on and look at another little skill and some more exam style questions. So good, let's have a little look. Well done, lovely. Okay, excellent. So we're going to do that quickly. 7, 3 take away 1 is 2, 0.27. Superb, well done guys, lovely. Excellent. So if I move on, what we'll do now, we're going to look at multiplying and dividing decimals. But what I would like to do is go through some, excellent guys, some different techniques, because sometimes not everyone does column method or does the same techniques for these. So I'd like to go through a few different ways of doing this. So we can do multiplication involving decimals by temporarily bringing back the decimal point in both numbers. So make it as easy as possible and then worry about the decimal at the end. Does everyone recognize what I'm saying? Do you guys treat it in that sort of way? Like ignore the decimal for a minute. Yeah, excellent. So bringing back the decimal point in both numbers. Yeah, good, good. So what we'll do is we're basically looking at how to multiply here, and then just tweaking our numbers accordingly. So the easiest way to think of it is 6 times 12. Lovely, well done, guys. So think of it as 6 times 12. We've made that 100 times bigger. We've pushed it sort of 2 columns up. And so what we would get, 6 times 12. So 6 times 2 is 12. And 6 times 10 is 60. So 72. And then I need to make that 100 times smaller. So 0.72, absolutely. So I think that's a really good way of doing it. And then hopefully that sort of makes sense as well. It looks sensible as the answer. So 6 times 12 is 72. So 6 times something 100 times smaller than 12 is 100 times smaller than 72. We just put it 2 decimal places back. So 0.72. Brilliant. Now this one, let's be careful. And again, do feel free to work ahead of me with this, but we're having to tweak both numbers. So this time, if I take it as 71 times 13, which is absolutely fine, is everyone happy that the net effect is I've made it 1,000 times smaller, this calculation? Because I've made it 1,000 times bigger, sorry. So I'm going to need to shift it by 3 decimals at the end because I've made this 100 times bigger and this 10 times bigger. Yeah, okay. No worries. Yeah, so good comments and really good points you guys are making. Does that make sense to everyone though, that if I shift them so that they're both integer values, they're both whole numbers, then I just need to worry about what's the net effect? What do I need to change at the end? So now I can calculate 71 times 13. 3 times 1 is 3. 3 times 7, so that's 3 times 70 is 210. 10 times 1 is 10. 10 times 70 is 700. If I add it all together, 9, 2, 3. And so my actual answer, can you guys tell me how I tweak that? 923 divided by 1,000, shifted 3 columns back. What am I going to get? 0.71 times 1.3. 0.923. So I think, yeah, we've had a good few questions coming in there about the zero and where we sort of place stuff. I like to personally think about it about place value and how much you've had to move it all. Yeah. So, and also guys, sense checking is really still important because is everyone kind of happy that we've times 0.71 by 1 and a bit? So 1 and a bit just makes it a little bit bigger. So making something a little bit bigger than 0.7, 0.92 seems feasible. So that is how you could sense check it as well. Because sometimes with these things, again, we think, oh, if I mess it up, I'm not going to spot. But you can kind of get a sense of the magnitude the number should have. It shouldn't be in the 90s. It shouldn't be in the hundreds. It shouldn't be in the 900s. 0.923 is actually a sensible answer, just looking at it, just a bit bigger than 0.7. So hopefully that sort of thing can help us check and move on with confidence as well. Very well done, and thanks for sharing answers and questions in the chat. The next couple, I'm actually going to do a little bit differently because sometimes you get a bit bored of the column method. So I'm going to do this one using, I think the technique's often referred to as Gelatia or Gelatia. I don't know if anyone's done it this way. I think it's a really cool looking technique. Some people will find it a little bit tedious. Has anyone done this before? I really like it, but do kind of challenge what we're doing if you're not sure what I'm doing here. There's no problem. So one way of multiplying 97 by 54. Right, it's really cool. I'm going to show you how it works. But if you think, do you know what, I prefer the column method, no worries. But I thought it'd be nice to show everyone this technique as well. Right, so the way this works is if we try and work out 97 times 54, it's not as complicated as it looks. I think it's really cool. So what you do is you break the diagonals for each box and you literally just do 7 times 5 here. So 7 times 5 is 35 and you write it in. Okay, cool. Yeah, it's one of these that sometimes trends every now and then. I'm going to do this now. It is really cool. So 35, but that's funny to hear. Excellent. 7 times 4, 28. 4 times 9, so if we fill that in, is 36. And 9 times 5 is 45. And then it's really quite neat. What you do is you kind of add up the diagonals columns and you get your answer. So you do 8 plus nothing is 8. 6 plus 2 is 8 plus 5 is 13. Carry the 1 into the next column. And then what you're going to get here, now 3 plus 5 is 8, 9, 10, 11, 12. 2, carry the 1, and that would be 5. And that's your answer. 5, 2, 3, 8. Yeah. So then what do I need to do for that answer? Now, if you thought, you know what, I could have just done the column method, that's fine. But I think it's quite a cool method to go through. So I'm going to go through it again in a minute. But just remember here, guys, we've moved this 2 places there and another one there. So this needs to be moved 3 places back. So this will be 5.238. So if you got that value, yeah, excellent. So if you've got that value there, whether you use column method or whether you use this method, tweaking it and moving it back is still really important. So moving it back to 5.238, again, how could we sense check that? Well, it's roughly 10 times roughly 0.5, roughly half of 10, roughly 5. That looks like a sensible answer. 52 point something would have been too big. 523.8 would have been way too big, and 5,000s would be way too big. So that is the correct sort of magnitude. And that's your answer. So let's do it for this one here. I'm going to do 43 times 72. And again, just because it's quite fun, let's use Gelatia. 7 and 2. I'm going to draw it out. And it's actually quite neat. Okay, cool. Right. So we'll do it, but if you guys want to, if you prefer to do column method, then go for it. No worries. But hopefully we will arrive at the same answer. So whatever method is best for you. 3 times 7, 21. 3 times 2, 0, 6. 2 times 4, 0, 8. 4 times 7, 28. Let's add up the diagonals. 6, 8 plus 0 plus 1 is 9. 8 plus 2 is 10. Carry the 1. And we get 3. So I make that 3,096. And if you did it a different way, no problem. And then we need to be careful here. Now this decimal, we've moved it 1, 2, 3, 4 places up. So this calculation is like 4 columns too big. So I need to move it back by 4 columns. So my answer will actually be 0. And we'll be careful here, hang on. So if I move it 4 places back, 1, 2, 3, 4. Yeah. Yeah, I agree with that. I think that's good. Well done. Cool. Yeah. Excellent. So we're going to move on. And now division as well. So division, what we can think of here, very much the same sort of thing. I'm going to just change my pen back. By multiplying both sides by a power of 10. So you can think of this as 50 divided by 20. Oh, sorry, but divided by 2. Because remember, this is like 5 over 0.2, which is equivalent to 50 over 2. And that might be easier to work out. So it's the same division. So like that is the equivalent division if you times both bits, scale it up in the same proportional way, and then that's quite easy to work out. 2 will go into 50 25 times. 0.2 would go into 5 like whole 25 times as well. So that might make it a bit easier to do. And likewise for this one, if I made this 64 divided by 0.4, that would be an equivalent calculation. And it would also be the same as 640 divided by 4. So I personally think 640 divided by 4 is a bit easier to work out than this, but they would have the same answer. So that's how I would probably go about it. So 4 into 6 goes once. 4 into 4, sorry, remainder of 2. 4 into 24 goes 6 and then 0. So the answer is 160. Okay. Is everyone okay with that? Yeah, we'll do a couple more and then we'll look at some exam questions, but really well done today. Yeah. Oh, okay. Yeah, I actually think that's a really good point. Actually, I think division is really nice to do as fractions. Like if you're quite confident at simplifying fractions, there's no problem with doing a division as a fraction and then just cancelling it down as far as you can. That's a really good point. So like here, 1.8, you can think of as, so the way we could do it is we could do it as 18 divided by 6. I know I've not done it for both, but if you do 18 over 6, that's 3. But then my answer to this needs to be 10 times smaller, so 0.3. Now, likewise here, 60 divided by 0.005 is the same as, if I make this 1, 2, 3 columns bigger, 60, 1, 2, 3 divided by 5. Yeah, good. And so then that is going to be, so we do 5 into 60, 12, so that's 12,000. Okay, very good. Right, there's a few more. I'm just conscious of the time, so you guys could maybe try those in your own time. You could use Gelatia for this one, or you could just use column method or any other technique. Just a little quick checkpoint, guys. If you could just give me a 1, 2, or a 3 for how you're feeling. Looking at the chat and the answers, I think everyone's fairly confident with this, which is great. And then what I want to do is just round off with a few kind of exam questions to see how it could come up. And then what we'll do is, yeah, we're getting quite towards the end now. So we've done really, really well. Lovely. Great. Thanks, guys. So what we've got, here we go. State with calculation, which calculation, sorry, in each of the following pairs has an incorrect answer. Explain how you can tell without giving the correct answer. So which one is wrong and why? So is it A or is it B? Which one looks like it's wrong? And I would go through each and just sort of check what would I do here? How would I work that out? And actually, if you had the first one is actually really quite quick to work out. If you did 3 times 4 is 12. How many zeros would we need to put on? How many places have we got to tweak? 1, 2, 3, 4, 5. So actually A is wrong. And the reason is there's not enough zeros. Okay. Yeah, so you just multiply 3 and 4, but we'll just be careful with the zeros. Okay, and then this one here, C and D, again, haven't necessarily got to work out the final answer. But this one here, if you guys have worked it out, like, because they're all quite close. If you divide by a number smaller than 1, the answer actually gets bigger. So if you divide by a half, it actually doubles something. So D is actually wrong, because the value should have increased, because we're dividing by something less than 1. Very good. Right, and then the next one, 1.6 times 4. So let's work this out. 1.6 times 4. You might want to do 16 times 4 and then make your answer 10 times smaller. Feel free to share in the chat. Hopefully we agree with that. And then this one here, yeah, so we might want to treat it as 819 divided by 30. Yeah, very good. So 819 divided by 30. That's absolutely fine. You can do it that way. Very good. I'm going to just write this out here. And you might want to first divide it by 3, then divide it by 10. It's up to you, however you guys want to do it. So if you divided it by 3, 3 into that goes twice, with a remainder of 2. And then make that 10 times smaller. Okay, hopefully we're all okay with that. So what I'm going to do is one more exam question here. Felix wants to work out how much it costs him to use his tumble dryer. The tumble dryer uses 1.9 units of electricity to dry 1 load of washing. Felix dries 4 loads of washing each week. He pays 12.8p for every unit. Work out the weekly cost. So what we want to do, no worries, is work this out. So 1.9 times 4 is going to be, well, 4 times 1 is 4, and 4 times 0.9 is 3.6. So 7.6 units per week is what Felix is using. And each unit costs 12.8p. So I want to do 7.6 times 12.8. So what I'm going to do is I'm going to do 128 times 76. Oh, good question. It does 4 loads of washing per week. There's quite a lot of information in there. Good question, yeah. So we've got there was a lot going on, and these wordy questions can be quite annoying. So I'm going to quickly whiz through, do this one. So 8 times 7, 56, 8 times 6, 48, 2 times 7, 14, 2 times 6, 12, 1 times 7, 0, 7, 1 times 6, 0, 6, 8, 10, 12, carry the 1, 6, 10, 11, 17, carry the 1, 1, 2, and 9. So I'm getting 9, 7, 2, 8. And I need to make this a bit smaller. I need to make it 2 columns smaller. So 97.28 pence. Yeah, no problem. So the way we did this, there's a lot going on there. The tumble dryer, basically Felix is using the tumble dryer 4 times each week. And every time they use it, it's 1.9 units of electricity. So it's 1.9 4 times a week. So that's 7.6 units for the amount of drying, the amount of time they're using it to dry the washing each week is using 7.6 units of electricity. Each 1 unit of electricity costs 12.8p. So you're using 12.8p's worth of electricity this amount of times. So if you multiply the two together, it will give you the cost for all the drying across the week based on the units used. Okay, so this is the total units used for the 4 times that it's used with that amount of electricity each time. And then this is the 12.8p multiplied by the amount being used. Is that okay? No worries. Brilliant questions and superb answers as well today, guys. Really pleasure working with you all there. Good luck with the rest of the half term and the kind of lead up to the next break. The worded questions are tedious, they are tricky, and most mathematicians feel the same about that. So I completely understand how you feel with that one, but it's just preparing and slowing yourself down and taking your time with them. But really well done. We've kind of recalled the basics, and then taken them further to solve GCSE exam style questions and looked at the 4 operations for decimals as well. So what I'm going to do, I am going to wrap this up, but do keep an eye out for the upcoming web classes on the Sundays, and obviously keeping your eye open for the kind of information coming through about the GCSEs. I'm sure you guys are preparing well, but yeah, as I said, for topics like this, non-calculator stuff, slow yourself down and just work through it carefully, and then have little sense checking techniques in place for towards the end. That's great. So really well done. Have a good rest of the weekend. And thank you again to everyone for taking part so well in that. It was lovely to hear answers and questions. Okay, yeah, no worries, guys. Don't panic. And as I said, really well done today. So I'll let you guys go, but thanks again and keep well and great work. Cool. See you later. Bye.